Good morning, class. We are looking at practice test number 1, exam review number 1, covering module 1, chapters 5 and 6. Chapter 5, trigonometric functions. Chapter 6, sections 6.1, 6.2, periodic functions. We want to answer the following. Convert 315 degrees to radians, 9 pi over 5 radians to degrees, and so on and so forth, meaning we are going to go back and forth. And one shorthand formula is d over 180 degrees is r over pi. And in this formula, you replace whatever is missing, whatever is given, and you find whatever is missing. For example, for part A, 315 degrees goes up here. And you find the missing r by the cross product. Or one might say 1 degree is pi over 180. You can multiply it by pi over 180 again. So that's one way to do it. Simplification will give us 7 pi over 4. In this case, we want to convert 9 pi over 4 radians to degrees. You can replace the r with that. Or instead of pi over 180 times the reciprocal of that, 180 over pi. Obviously, this pi and this pi cancel each other. 180, since it ends with 0, is divisible by 5. 9 times 36, or 324 degrees. Three radians. You can put it here, and the cross product will give you the answer, or again times 180 over pi, which makes it 3 times 180, or 540 over pi, and you go with however many decimals they ask you, and you come up with the answer. We want to find the exact value of sine of 14 pi over 3, and reminding everyone that 2k pi, or better yet, 2 pi, is the period of all trig functions except tangent and cotangent, which is pi. So for sine is 2 pi. So multiples of 2 pi you can take out. The same thing for cosine. So multiples of 2 pi. So sine of 14 pi over 3, remember, this is larger than 2 pi. And you may know that 12 pi over 3 is 4 pi. And you can take out. So it becomes basically sine of 2 pi over 3. Now, the reference arc is pi over 3, so it has the same value as sine of pi over 3, but is it positive or negative? It's in the second quadrant, and sine is positive. Therefore, it's identical to sine of pi over 3, which is square root of 3 over 2. We're going to answer the following. Name the quadrant that contains the terminal point of the arc t equals 2. Justify your answer. So we're going to write everybody remembers the unit circle x squared plus y squared equals 1. P has coordinates x comma y. This one has coordinates 1, 0, so on and so forth. So this represents the 0 degrees. This represents the 90 degrees or pi over 2, 180 degrees or pi, 270 degrees or 3 pi over 2, and a complete revolution is 2 pi or back at 0. Now, we want to know where number 2 ends up being. Let's remind everybody of a couple of things. X squared plus y squared equals 1. Y represents the sine and x represents the cosine, and tan is the ratio of sine to cosine. Also, tangent is sine over cosine. Cotangent is cosine over sine. Cosecant is 1 over y, or the reciprocal of sine. Secant is 1 over x, or the reciprocal of cosine. Just to remind you of a few things that we have seen would be helpful. Now, we also know that pi over 2 is about what number 1.57. Pi is 3.14159. It continues indefinitely, about 3.14. And 2 pi is about 6.28. So we write them. So when t is between 0 and 1.57, puts it in the first quadrant. When t is between 1.57 and 3.14, puts it in the second quadrant. Again, if it's not given as multiples of pi, if you will. If it's between 3.14 and 4.71, it's in the third quadrant between pi and 3 pi over 2. And if it's between 4.71 and 6.28, that, which is about 2 pi, that's the fourth quadrant. In our case, number 2, where does it end? Number 2 ends here. 2 is between these two numbers. Therefore, in our case, the answer is quadrant 2. We want to find the exact value of cosecant 11 pi over 2. And of course, and clearly the reference arc is pi over 2. And we can take multiples of 2 pi out. This is larger than 2 pi. So we can say it's 8 pi over 2 and 3 pi over 2. Why 8 pi over 2? Because this is multiples of 2 pi itself. That is 4 pi. So you can take it out. So it's the same as cosecant of 3 pi over 2, which makes it 1 over sine of 3 pi over 2. And you know, sine is -1, so the reciprocal is also -1. So please understand, we took out multiples of 2 pi. So anytime the number is larger than 2 pi, you can take them out in this manner. Determine the length of arc of a circle and area of a sector formed by the central angle theta, if theta is 1/2 radian and r is 10 meters. Let me remind everybody of both cases. This S equals r theta is the arc length. This area, this portion of the circle is called a sector, is half of r squared theta. So S equals r theta. Multiply the r, which is 10, by theta, which is 1/2. Clearly, the answer is 5. meters. The units would be the units of the radius. The area is 1/2 r squared theta. Replace the r with 10. Theta is 1/2. And it's important to know it has to be in radians. So as you can see, the numerator is simply 10 squared or 100. The bottom is 4. 100 divided by 4 is 25. The units of area, since this is in meters, this is in meters squared, or you can see it right here. This is 10 meters times 10 meters, which is 100 meters squared, and then divide by 4. I wanted you to see them side by side. What is the difference? The difference is that now this is in degrees, and of course, it's one of those common arcs. You know it's pi over 3, so you can do it in your head. You don't have to go through the process. And now that it's in radians, we can use it. S equals r theta 5 times pi over 3. And that makes it 5 pi over 3 precisely, units feet, and roughly, when you use a calculator, 5.236 feet, and the number of decimals, you want to be careful however many they ask you. As for the area of a sector, of course, 1/2 r squared theta, and r is replaced with 5, so becomes 5 squared or 25. Theta is replaced with pi over 3. So you can keep this as 5 squared if you want. Which makes it 25 pi over 6 precisely. And again, using a calculator with a bunch of decimals, 13.090 square feet. The units of the r is in feet, so square for the area.
I have a question.
Go ahead.
So on the test, will it be asking not only for the central angle, but also for the area? Because I know for the questions, it just says central angle.
I'm sorry, could you repeat that? For some reason I didn't understand it. Could you say it again, please?
So on the exam, will it be asking like for the central angle and area? Because I know on these questions, it says only the central angle.
Well, the thing is, yes, of course, if you look at the top here, determine the length of an arc of a circle and area of a sector. So when you take the exam, you just pay attention to whatever they ask you, okay? In this case, at the very top, it's asking for both part A and part B. The information is given, but right here.
Okay, thank you.
My pleasure. All right, now let's look at this question. Each wheel of a car with a radius of 15 inches makes 3 revolutions per second. How fast is the car moving in miles per hour? Meaning we are interested in finding the linear velocity. Okay. And so let's look at a couple of things, remind everybody of some of the formulas we've learned. Linear velocity v is defined as distance over time, so s over t. So the arc length divided by t. The angular velocity is defined as omega equals the amount of angle we cover over the time, theta over t. And it could be in the form of a revolution per minute, RPM, or revolution per second, RPS, and so forth. So in that case becomes 2 pi times that, because each complete revolution gives us 2 pi radians. So since V is S over T and S is R theta, we can separate it into R times theta over T. And therefore, V is R times omega. So this is just to remind you of how we arrived at those. But now, going back to the question, anytime you do word problem, it is extremely important to write the given. So let's go back and reread the question. The radius is 15, so R is 15 inches. It makes 3 revolutions per second. Omega is 3 RPS over here, RPM per minute, now RPS. And we are interested in V. So we're going to write it in this format because the given really helps out. Now, omega, that's the first thing we want to take care of it because we want to go with different units, 3 revolutions per second. That means 3 times what? Each revolution is 2 pi. So RPS or RPM must be multiplied by 2 pi. And the result would be 6 pi. Now it's radian per second because we want to take him to radians. Okay, revolution. A revolution is 2 pi radians. V equals R omega. V equals R omega. Let's plug in. So V is 15. Omega in radian per second is 6 pi, making it 90 pi inches per second because the R is having a units of inches. Now we want to go with miles per hour. So it's inches per second. We want to get rid of it and make it miles per hour. So everybody knows a couple of things. 1 foot is 12 inches. Obviously, 1 hour is 60 minutes. 1 minute is 60 seconds. Everybody knows that. And 1 mile, you can say 1 hour is 3,600 seconds, either way, is 5,280 feet. Now, what does it mean? I want to make sure everybody understands the meaning of it. Now, the unit conversion, we can say 1 foot over 12 inches is 1, or 12 inches over 1 is 1. Makes no difference. Those are unity. 1 mile over 5,280 feet or 5,280 feet over 1 mile. They are unit conversion. But which one goes at top? Which one goes at the bottom? Remember, ultimately, this must be changed to this. Okay? So that means the hour must be at the bottom and the mile must be at the top. That's the bottom line. So let's make the changes. So 1 foot is 12 inches, cancels out this one. 1 mile is 5,280 feet. This one cancels. So this one cancels out this one. This one cancels out this one. And then 1 hour is 3,600 seconds. So now that you know that, all you have to do is say 90 pi times 60 divided by 12 times 5,280. Those are 1. And whatever the answer that it gives us, it becomes 16.065 miles per hour. So I want you to pay attention to the unit conversion that I did for you. And again, figure out which one is at top, which one is at the bottom. If the length of an arc S is 50 inches in a circle with a radius of 6 inches, find the angle theta that this arc subtends. Well, again, let's write the given. S is 50 inches. R is 6. And in this case, we want theta. As you know, S is r theta, and therefore theta becomes S over r. Again, all of the formulas that we have seen it previously, and they are useful. So simply put, plug in 50 over 6 is the final answer, which becomes 25 thirds radians. Very straightforward. We want to find the area of a sector formed by the central angle theta. So for the same question, we want to find A equals 1/2 r squared theta, which means 1/2 times r6 squared times theta 25 thirds radians. And you may see that 2 and 3 cancel out one of those. There are two sixes, 6 times 6. So 6 times 25 is 150 inch squared as the final answer.
I want to ask
Go ahead.
for A, what happens if we take a multiple of 2 pi's from the answer? We change because it's going to be the same angle.
No. We can't, because we have to keep them in the format that they want. Otherwise, we get a different answer. Because what happens, it does have an effect on the area that it covers. For example, if we go twice around the circle, it covers twice around the circle the area. That's what it means. So the area of a sector they're referring to depends on how many times you go, for example, around the circle. So you shouldn't change anything. That's different than what we have been doing before. So in this case, whatever the angle, you keep it. You just have to make sure it's in radians.
I also have a question.
Go ahead.
Yeah, so I'm kind of curious about how did we cancel out the 3 again?
This is 6 times 6, isn't it?
Yeah.
So one of them cancels out 2 times 3.
Okay, that makes sense. All right, thank you.
Sure. All right, we want to find the linear velocity of a cylinder with a 2 feet radius that is spinning at 40 RPM, revolutions per minute. So again, we have those formulas. Let's write the given. R is 2 feet. Omega is 40 RPM. V is missing, the velocity. First and foremost, this must be changed from revolution to radian, so that's why it has to be multiplied by 2 pi. We multiply 2 pi by RPM, 2 pi times 40, and we get 80 pi radians per minute. V equals R omega. R is 2, omega is 80 pi, and we get 160 pi. 160 pi, class. If this is the exact answer, then you use a calculator, a rough estimate of 502.65 feet per minute. So pay attention to the fact this is exact, and they may want you to change it to decimal format. So they want pi to be changed. So by the way, don't ever use 3.14 for pi, okay? Use a calculator, it's 3.14159, and it continues indefinitely. Find the exact value of each of the remaining trigonometric functions of theta, given that tangent theta is negative square root of 3 over 3 and sine is positive. So let's see what we know. First, I want to remind you of this concept again. Remember, x squared plus y squared equals 1. the unit circle, x is cosine and y is sine if we happen to have a general case where x squared plus y squared equals r squared, and then sine is y over r and cosine is x over r. So if we happen to have a general case, it's not necessarily one. And these are the formulas you've seen. Again, I want to remind you of, there are two, you can do that. You can use identities, whatever you're comfortable with. But what we have right now, tangent is negative, sine is positive, and that gives us the second quadrant, and theta is 5 pi over 6. I want to make sure everybody understands how we arrive at it. It is important to know this is a common arc, theta, okay? And I hope you remember that. Let me write it at top here. Tan of 30 degrees or pi over 6 is square root of 3 over 3. This is theta of r is pi over 6. The reference arc, so you can go that route. Since this is negative, it has to be in the second or fourth quadrant. Since sine is positive, has to be the second quadrant. And since this is the case, you can write the rest of them just using the fact that it's 5 pi over 6, okay? It is a common arc. However, if it wasn't a common arc, the number was slightly different. One approach would be as follows. Tangent is y over x. And so square root of 3. It is minus. You can put the minus in front of a fraction and then decide whether it goes with the top or the bottom. Since we are in the second quadrant, x is negative and y is positive. X is negative and y is negative. And now if you plug it, so you have it. In order for you to plug in, again, if you want to go with those formulas, you have to find the r, where x squared plus y squared is r squared. So this becomes 9, this becomes 3, so they add up to 12, I hope. You see that this is 9, this is 3, so this is 12. And r is the square root of 12. And as you know, square root of 12 is 4 times 3. 4 comes out as 2, square root of 3 remains. So sine is y over r which makes it 1/2. And you can write again the rest of them, or just remember 5 pi over 6. However you look at it, you can see sine is 1/2, cosine is negative square root of 3 over 2, tan theta is minus square root of 3 over 3, cotangent is the reciprocal of that minus square root of 3. Cosecant is 1 over sine, so makes it 2, and secant is 1 over sine, makes it minus 2 square root of 3 over 3. However you look at it, it's fine. As long as you have 2 of them, you can find the rest of them. But more importantly, you can go with your knowledge of common arcs, unit circle, or just a circle center that the origin or identities, unless they ask you specifically which method. Find the exact value of the remaining trigonometric functions where we know secant is 2 and sine is negative. Remember, secant meaning 1 over cosine. So right away, because secant is 2, cosine is 1/2. So cosine is positive. That's the concept. And sine is negative. And that makes it quadrant 4. I hope everybody can see that. So cosine is positive. Remember, cosine is positive in the first and fourth quadrant. So cosine or secant, positive, right? Positive means first or fourth. and sine is negative in the third or in the fourth, and the common would be the fourth one, and it makes cosine 1/2. You can use various methodologies to come up with the answer. Okay. Because it's 1/2, then pi over 3 is the reference arc, and you can use that, of course, in the fourth quadrant would be 5 pi over 3. So we know theta is 5 pi over 3. You can go that route if you want, okay? However, if you want to go with identities, and I mentioned that in case it's not one of those common arcs, you can go with sine squared and cosine squared is 1. So sine squared and 1/4 is 1. Sine squared is 3/4 because you're going to subtract 1/4, right, class? It's plus minus the square root of 3/4, and we know sine to be negative, so minus square root of 3 over 2. As I mentioned, you can go with the arc because from here you can find the arc, okay, since it's in the fourth quadrant, okay. As I mentioned, 5 pi over 3, or take it from the... Now, of course, tangent is sine over cosine. Cosecant is 1 over sine. Cotangent is 1 over tangent. So 1 over sine, so the reciprocal of this minus 2 over square root of 3. Normally, we rationalize this by multiplying by square root of 3 over 3. I guess that's elementary. We shouldn't worry about that. I'm sure you know how to handle it. Tangent is the ratio of sine to cosine. Makes it minus square root of 3. And cotangent is the reciprocal of that. Makes it 1 over minus square root of 3. Which is minus square root of 3 over 3. So, and normally when you write this class, it's a good practice to write everything somewhere though, so it becomes organized instead of somebody having to look for each and every one of them. Again, what I mentioned, I'm going to quickly write it for you. This means, everybody, the reference arc, excuse me, is pi over 3. And because it's in the fourth quadrant, theta is 5 pi over 3. And you can use that and get to the information here. So there are many different ways. I just wanted you to be exposed to various methodologies, whether we use the unit circle or a circle which is not centered, which is not a unit circle but centered at 0, 0, using identities, so on and so forth. We want to simplify secant of pi over 4 and cotangent of pi over 4. We are multiplying them. As you know, secant is 1 over cosine. And the reason we go there because we know cosine of pi over 4 is square root of 2 over 2. Cotangent of pi over 4 is 1. So this flips over as 2 over square root of 2, which is square root of 2. All right. We want to combine these two fractions. So simply put, we take a common denominator. The least common denominator is simply the product of these two pieces, sine theta, cosine theta. So you multiply this one by cosine, minus you multiply this one by sine. So sine theta, cosine theta, plus cosine squared theta, minus sine theta, cosine theta, minus and minus, plus sine squared theta. I hope everybody can see that. Let me just write this at top so in case. So what we are doing here is cosine theta times sine theta plus cosine theta minus sine theta times cosine theta minus sine theta. That's what we are doing, class. Okay, I want to make sure that we are okay with that. Sine theta, cosine theta, minus sine theta, cosine theta, they cancel each other. We only have sine squared plus cosine squared in the numerator. One of those Pythagorean identities, you should know that's equal to 1. So let me remind you. Sine squared plus cosine squared is 1. 1 plus tan squared is secant squared. 1 plus cotangent squared is cosecant squared. The numerator, which is the sum of cosine squared and sine squared, becomes 1. Now, if we cut this into two pieces, this becomes 1 over sine times 1 over cosine. As you know, 1 over sine, the reciprocal of sine is cosecant. 1 over cosine, the reciprocal of cosine is secant. And that would be the final answer. All right, we want to simplify this expression again, reminding you of various identities. For example, Pythagorean identities, I hope everybody knows by now. So to do this, you may recognize sine squared plus cosine squared is 1, or just put them next to each other first, if you want to do that, and then say it's 1. So put these two together next to each other. You don't have to do that, but you know, this one and this one, 1. And 1 plus cotangent squared is cosecant squared. So cosecant squared theta is the final answer. Cosine of pi over 6 times secant of 13 pi over 6. So first and foremost, notice this is larger than 2 pi. So if I wrote that as the sum of 12 pi over 6 and pi over 6, let me tell you why 12 pi over 6. I want multiples of 2 pi, okay? And as you know, 12 pi over 6 equals 2 pi. So I can simply put pi over 6 instead of 13 pi over 6. Okay, so I'm taking 12 pi 6 away. So this is 2 pi plus pi over 6. As you know, secant is 1 over cosine. So I can say cosine divided by cosine, which makes it 1. Cosine of pi over 6 over cosine of pi over 6 equals 1. We want to add them up, and I'm going to remind you again of the periodic function. All trigonometric functions are periodic functions, and all of them have a period of 2 pi except tangent, and with that goes cotangent. So all of them 2 pi except tangent and cotangent. Therefore, this is cotangent, so is this one, so is this one. Whether we add pi or subtract makes no difference. Whether we add 2 pi or subtract makes no difference. So there are 3 of them. Find the amplitude, period, intercepts, and phase shift of the function. Sketch the graph of a complete cycle or period y equals negative sine pi over 3x plus 4. Okay. Let's remind everyone of a few things. A complete cycle of a sinusoidal function, one way is to cut them into 4 arcs. This is one of them, 0 to pi over 2. This is the second part, pi over 2 to pi. This is the third arc, pi to 3 pi over 2. And this is the last one. From 3 pi over 2 to 2 pi. And all we have to do, find 1, 2, 3, 4, 5 points. That's a graph. That's really the fastest way to do that. And so if it's 2, whatever the period is, you cut them into 4 parts. Okay. Now, the domain is all real numbers from negative to positive infinity. This is just one complete cycle. The range is negative 1 to 1. T is 2 pi, amplitude A equals 1. What happens if we generalize it? There are two forms to write this. And that would be, I thought I had it here. Sometimes they use omega here. And this is phi. Okay. It makes no difference. Okay. Actually, this one, no. This one I want to take the B out. My apologies. But I wanted to mention instead of B, they may use omega. And this becomes y over omega, depending on the text. I've shown you that. All right. The period would be, if you have it in this format, 2 pi over b, amplitude is absolute value of A, PS short for phase shift, or the horizontal displacement of C over B or phi over omega. If C is less than 0, phase shift is to the left, and if it's positive, it's to the right. And this line, okay, remember, this shifts it up and down. So you can graph this, and by this much go up or down, called the midline of a function. Is the horizontal line midway between the max and mean values of a function. For y equals sine theta, the midline is the line y equals 0. So the midline would be the x-axis on a normal basis, okay? The horizontal axis. And in general, the midline would be y equals d. So just to remind you of that. Now, we are going to go back to the same question now from the scratch. And the information that I mentioned the previous page, depending on the text, we may have an omega here class and then phi here, okay? It really doesn't matter. And then this one, instead of D, they may use B. This is actually, I think, more popular, but doesn't matter. The point is how you deal with that. So let's start with this. Obviously, we have the amplitude is the absolute value of negative 6 makes it 6. T is 2 pi over omega, or 2 pi over b, or 2 pi over 3. And it makes it 6. There's no phase shift. Okay. So the t period of 2 pi, we used to cut it in 4. Now we cut the period of 6 into 4 equal parts. Divide the number by 4, gives us 3 halves, which means we're going to go from 0 to 3 halves, and then 3 halves to add 3 halves to it gives you 3, and then another one, and then another one. So 0 to 3 halves, then 3 halves. If you add 3 halves, you get 3. Then 3. If you add 3 halves, gives you 9 halves, and 9 halves when you add, it must give you this last one, number 6. If this doesn't give you the proper number, somehow in the calculation we made a mistake. And what is the vertical shift of positive 4 units up, 4 units up? Now, there are 2 ways to do this. You could ignore that, look at this, come up with the key points, and then shift it up by 4 units, or just plug it in right now. For example, if I plug in 0 here, this becomes 0. Sine of 0 is 0, times any number is 0, the answer is 4. So one of the endpoints is 0. That's, I give you a couple of them. So 0 gives you 4. What about 3 halves? Let me just, 3 halves are 1.5. So if I put here, instead of x 3 halves, I get pi over 2, everybody. I get minus 6 sine of pi over 2 plus 4. Everybody knows sine of pi over 2 is 1 times minus 6 is negative 6. With 4 becomes negative 2. So if I put 1.5 or 3 halves, I get negative 2. So I did this one. I did this one. Let me do one more. Let me do 3. So if I replace this with 3 now, class, if I replace this with 3, what do I get? Minus 6 sine of a pi plus 4. As you know, sine of pi is 0, therefore I get 4. You can figure out the rest of it. Maybe, let me do 9 halves. Let me do 9 halves. I want to make sure that, let me do 9 halves or 4.5. So let me use a different color. So negative 6 sine of pi over 3 times 9 halves plus 4. So minus 6 sine of 3 pi over 2 plus 4. As you know, sine of 3 pi over 2 is negative 1 times negative 6, positive 6, and 4 is 10. And actually 6 is very, if you put 6 here, you get 2 pi sine becomes 0. This is 0, so you get 4. So this is what you get. So actually I showed all of that. Now, of course, you can go to the left side because this shows a complete cycle. You can go to the left side, and if you graph this, this is y equals 4. Okay. The midline is y equals 4. And here's the graph. Take a look at those pairs. Take a look at the complete cycle, everybody. Remember, it's sign that it has flipped over because of this, in essence. And This is your horizontal axis or the x-axis. Let me quickly look at the same thing, slightly different. So we have done all of that, okay, and D is 4. And we have this information from the previous page. So this is y equals 4. Y equals 4. And all you have to do, plot those pairs as follows. Plot those first, because if it was along the x-axis, would give us the x-intercepts. And the reason they are no longer x-intercepts because it has been shifted up by 4. So we get this point, and this point. I hope you remember that. Those are the x-intercepts have been shifted up by y equals 4. Max and mean, right? And it's a complete cycle. Of course, you have to go indefinitely on both sides, class. Perhaps it's easier to follow that. It's up to you. We want to find the amplitude, period, intercepts, and phase shift of the function and sketch the graph of one complete cycle where y is 2 cosine 3x plus pi over 2. And I'm reminding you of the same thing we had over there. What works for sine works for cosine, meaning the same amplitude. And t is 2 pi over omega, 2 pi over b. And so let's get started. The very first thing, this has to come out, class. When you factor the 3 out, then you have to factor the 3 out of this. That means divided by 3 becomes pi over 6. That's the first thing. Why is it that we have to do that? Because for the period, we have to divide by 3. So the amplitude is absolute value of 2 or 2. The period is 2 pi divided by this number, whatever this number is, happened to be 3. And there's a phase shift. This is plus pi over 6. So the phase shift of negative pi over 6 moves that way. Now, what do we have to do? First, we're going to cut this into 4 equal parts. So 2 pi over 3 divided by 4 becomes 2 pi over divided by 12 or pi over 6. So divide this number by 4, you get 2 pi over 12 or pi over 6. So if we didn't have a phase shift, everybody, we would go from 0 to pi over 6, from pi over 6 to the next one, then the next one, and all the way we would end up with 2 pi over 3. Because of the phase shift, we have to start from here. So this goes to negative pi over 6, and this one goes to the left. We subtract pi over 6, or we add minus pi over 6. And the result is minus pi over 6 with this one. Then this is 4 pi over 6 with this is 3 pi over 6 or pi over 2. So please understand we are adding negative pi over 6 to this end, and that's what we end up with. And so now we're going to go from negative pi over 6 to pi over 6, negative pi over 6 to 0, then 0 to pi over 6, then pi over 6 to pi over 3, and pi over 3 to pi over 2, because we are just adding this pi over 6 to this one. We are adding pi over 6 to this number, we get 0. We get pi over 6 added to 0, we get pi over 6. If I add it to pi over 6, becomes 2 pi over 6 or pi over 3. And finally, when we add it to pi over 3, we must get the last piece, which is pi over 2. Now, what do we do? Evaluation at the endpoints. For example, negative pi over 6. So it may be easier that we use this one. So right away, if I put minus pi over 6, what happens, everybody? 0, times 3, 0. Cosine of 0, 1, times 2 is 2. So minus pi over 6 was easy. Let's do 0. If I plug in 0 here, I get 3 pi over 6, which is pi over 2. Let me just write the 0, for example. If I plug in 0, I get 2 cosine of 3 pi over 6. 3 pi over 6 means pi over 2. Cosine of pi over 2 is 0 times 2 is 0. Let's put pi over 6. So we did the first one. We did the second one. Let's do pi over 6. So if I put pi over 6 here, let me use a different color. If I put a pi over 6 here, class, with pi over 6, I get 2 pi over 6. 2 pi over 6 times 3 is 6 pi over 6, or simply put pi. So I hope you see that you get 2 cosine of pi is negative 1 times 2 is negative 2. Let's do pi over 3. Let's do pi over 3. So if I put pi over 3, I get 2 cosine of 3 times pi over 3, and pi over 6 is pi over 2. So 3 times pi over 2. And cosine of 3 pi over 2 is 0. So 2 times that is 0. Very straightforward. If you put pi over 2 and pi over 6, you can work it out, and you end up with 2. All right. So now all you have to do, plot those pairs. Okay, I'm talking about the 5 key points, okay, for a complete cycle. And then move on indefinitely on both sides. Continue on the right, continue on the left. Looks something like that. But these are the 5 key points that we started with. All right, find the domain and range, intercepts, and vertical asymptotes of the function. Sketch the graph, y equals tan of 1/2 x. And I remind you that when y equals tan x, the period is pi, the vertical asymptotes 2n plus 1 over 2, and then times pi, or 2n plus 1 times pi over 2. And x-intercepts happen at n pi and 0, just to give you an idea. So the very first thing we do, the period, which is pi, we divide it by 1/2 and it becomes 2 pi. So in short, anywhere you see pi, you change it to 2 pi. So this becomes 2 pi, this becomes 2 pi, this becomes 2n pi, just as an example. So this is the vertical asymptote. And if you recall, the domain is everything but those. And so it changes the vertical asymptotes as well as the domain. Because of the 2 pi, now the domain contains everything except n times y. The range doesn't change, it's negative to positive infinity. And the vertical asymptotes now are simply put n pi. As an example here would be, we have 2 pi minus pi and pi, x equals minus pi, x equals pi. And a couple of points if we want to put in, obviously, when x is 0, tangent is 0. When x is, let's say, pi over 2, times 1/2 is pi over 4, becomes 1. If it's negative, pi over 2 becomes negative pi over 4 and becomes negative 1. So those are, remember when we graphed them, we used pi over 4 and negative pi over 4 for a basic tangent. The period has changed. So according to that, okay, it was pi over 4 and 1. Now it's pi over 2 and 1. It was negative pi over 4 and negative 1. Now it's negative pi over 2 and negative 1. The 0 doesn't change. The vertical asymptotes, x equals minus pi, x equals pi. Those are the 3 points. And that's the graph. So basically the tangent that you know, the main thing is that what happened that the period is larger by a factor of 2. What about this one? What I find the amplitude, period, intercepts, and phase shifts of the function and sketch the graph where y is 3 cosine of pi x minus 4, and cosine and sine, they follow with the amplitude and so on and so forth. So the very first thing, of course, as you can see that the amplitude is absolute value of 3 or 3. The period is 2 pi divided by pi makes it 2. There is no phase shift, everybody. We're going to cut this into 4 equal parts. 2 divided by 4 is 1/2. And so we're going to go from 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. That's very straightforward. And you just plug in and observe. For example, if I plug in 0 here, cosine becomes cosine of 0, which is 1, times 3 is 3, minus 4 is negative 1. If I put 1/2, cosine of pi over 2 is 0. So this goes away. The answer is minus 4. If I plug in 1, just as an example, let's just plug in 1. I want it. So if I plug in 1, I get 3 cosine of pi times 1 minus 4. Cosine of pi is negative 1. So that gives me negative 7, just as an example. Those are easy calculations. If I put 3 halves, 3 pi over 2 cosine is 0, so minus 4. If I put 2, let's actually do the 2 with a different color. So we get y equals 3 cosine pi times 2, 2 pi minus 4. As you know, cosine of 2 pi is 1, so this is 3 minus 4 is negative 1. So that's how you calculate them. All you have to do, and these 4 units, so ignore that. For now, you can ignore that if you want, but understand the concept of it 4. So here's the 5 key points I calculated for you. 5 key points. Here's your D. The vertical shift of D equals negative 4. So this is the x-axis. It comes down by 4. We put those pairs. Okay. If you recall, those would be the x-intercepts if we didn't have negative 4. Putting them together, that gives us a complete cycle because we just want a complete cycle. Find the domain and range and vertical asymptotes of the function. Sketch the graph of one complete cycle where y is cosecant pi x. And I remind you that cosecant is 1 over sine. X can't be n pi. Ranges are real numbers except between -1 and 1, the way we write it, minus infinity to -1, union 1 to infinity. It's an odd function because sine is odd, so is that one. T is 2 pi, vertical asymptote n pi, x intercepts none. And so we start with sine. So in this case, sine of pi x. We're going to graph that. That means completely ignore the cosecant for now. The amplitude is 1. And the period is 2 pi divided by pi, making it 2. There is no phase shift. We're going to cut this into 4 equal parts. Divide by 4 and you get 1/2. So we're going to go, there's no phase shift. We're going to go from 0 to 1/2, then 1/2 to 1, 1 to 3/2, 3/2 to 2. Those are the 4, 1, 2, 3, 4 sub-intervals. Now, plug in 0. When you plug in 0, sine of 0 is 0. Plug in 1/2, sine of pi over 2 is 1. Plug in 1, sine of pi is 0. Plug in 3/2, sine of 3 pi over 2 is -1. Plug in 2, sine of 2 pi is 0. So very straightforward. We have those. Those are the x-intercepts. Those are the max and mean. And that's a sine graph, good old sine graph, not a big deal. So what do we do now? In order to cosecant, we flip this over. Basically goes like that, okay? And so what happens is, looks like that. Domain, x can't be n. Range, just like this one, because we haven't shifted up or down. The range changes when you shifted up or down. We didn't do that. A vertical asymptotes, if the domain is x can't be n, the vertical asymptote x equals n. For example, 0, x equals 0, x equals 1, x equals 2. Those are the vertical asymptotes for just one complete cycle.